Hi and welcome. This time around we have a project for the vacuum pump. As I promised a couple videos ago, and we'll be starting with this Blanchard ground steel plate, and we're going to take it over the surface grinder and make it just a little bit flatter. Okay, we've ground both sides of this guy, and you can see the edge here where it doesn't fit on my surface grinder because it's only 6 by 18 and this is 8 inches wide, but we did get there. And the sides are flame cut. I don't know if you can see that easily, but we're going to clean that up next. Once we get it square, we'll be ready to start. Next up, we need to make some custom T-slot holders for my rotary table. And they're going to be very unusual ones in that they are going to stick out here, which means I'll take the lock off, both locks off for that matter. Yeah, they're going to extend past the end of this guy here. That way I can hold parts that are bigger than fit on this table. Logging out some material to dimension. 50 thousandths depth to cut. The face mill was making it was only running at 500 RPM. I ran it faster, but it seemed to dislike that quite a bit. So I'm switching to a roughing end mill. We're going to run that at 500 RPM here and see if we can't remove this material. I'm going to do 150 thousandths. That was just a 50 thousandths pass, but it did not seem to be happy. I find that these end mills are freaking amazing, these corn cob. Slowed it down a little bit more, it sounds a little bit better, so we're going to go with that. It's not having any issue with it whatsoever. Removing stock from the sides to make the T. The part that sticks out is not supported well enough, unfortunately. Need to be in closer to the vise. Some pretty impressive chips coming off this thing. Second side. A lot of stick out there. If I'm going for precision, I would not do this. Here's the bar stock, the rough bar stock. I put it over the surface grinder and ground it really quickly. It's soft stuff, so it doesn't particularly grind well, and it scratches really easily. So the beautiful finish is going to go away quickly. And you can see where the grinding wheel has a little bit of bounce between, I don't know if it's grain boundaries or what, but it always happens with really soft materials unless you go super light. And this was, like I said, a really rough grinding. I think all in all, it took me like 10 minutes to do the grinding on this. So next up, we're going to cut this apart, and then we are going to drill and tap. Cutting out the individual pieces. After I rough cut them on the bandsaw, I trim them to size using an end mill. And the absolute size is important, but I'd like to have all three the same length. That way when I put screw holes, they all match up. It's not really a particularly big deal. These are not precision parts by any stretch, but I like the look of it. Now we have three to matching length, and we can drill for the tapping machine, which we will tap a bunch of holes. First up, we're drilling and tapping for 1/4 20, and that set screw will be used to hold this into the rotary table. It'll push against the bottom of the T-slot and force this guy up just to hold it in place so it can't move. I don't know if this is exactly necessary, but I thought I'd try it anyways. Next up, we're going to be drilling and tapping for 3/8/16. For the T-slot set I've got, I'm going to drill 2 holes to be tapped in the tapping machine. I'm still not sure about the second hole. I think maybe I'm going to let that one slide for a moment. We're just going to drill and tap for these 2. Just to give you an idea, this is going to be the edge of the 8-inch rotary table right about here. And then this is going to sit proud of that table, and then I'll be able to clamp things down out here, and it'll press against itself. So I can use one of the 3/8-inch studs in there, and we should be good to go. That's how it's going to be used. I'll show you more later. At least this is my idea. I think these will be useful to have even if it doesn't work out. So the next part we're working on is the base for the vacuum plate. So the reason why I say it's the base is because my vacuum plate's going to be in 2 parts. It's going to have the base plate, which has the vacuum in and distributes the vacuum, and then I'll have a removable, replaceable 3/8 inch aluminum, machinable vacuum plate for the top that actually goes to the work. And that way this part can stay fixed and the top doesn't have to get damaged. I think I've got some creative solutions to deal with that. This is not exactly dimensionally accurate. I just roughed the size based on the piece of material I had. So I'm going to do everything off center lines. So I've gone to find center this way and center this way. As you can see, here's what I'm going to do. The 1/2 inch or 1/4 inch NPT vacuum inlet is going to be over here, and it's going to pop up in here. This is my center line and my center line. So I'm going to drill and ream a hole in center, and then I'm going to drill slightly larger so I can tap and put a set screw in there to prevent the vacuum from leaking. But the prime job of it is to give me my center front and back, because I don't have a CNC machine. So in order to get these curves for the gasket, I need to find the center of those curves, and that's going to be done on the back by pre-drilling and reaming some holes that I take over the rotary table and try and do these 90s. Pretty spooky stuff. Never done anything quite like it, so it may or may not work. We will see. I'm just trying to figure this out as I go. So first, I'm going to prepare my center spot. So next up, I'm going to drill and tap for 3/8 16 threads. This little guy is going to go down in there to block the vacuum, and so I need to go down about 1/2 inch. And I didn't want to use an actual drill bit because I didn't want the end to be conical. I want it to be flat so that I could maximize this. So we're going to set our 0 here, and that's a 1/2 inch. That was a piece of cake. End mills make nice, relatively flat bottom holes. If you need an actual flat bottom hole, they will not work for you because they do have a little relief, but mostly flat bottom hole, more than enough for what I'm doing. This is a blind hole that ends in a flat, so I'm using a bottoming tap, and something you don't see me do a whole lot, which is manually tap, because I really hate it. When you have my poor coordination, it's a recipe for breaking taps. So maybe it makes a little more sense this way. There's my 1/4 inch dowel pin. Nice tight fit. I did it 1/4 inch with 1/1000th over so that it wouldn't be a problem going in and out. It's just to find my center. Next up, rather than the slot, since I've got my drill chuck in there, I'm going to drill and prepare them for tapping all of the mounting holes for the top plate of the vacuum table. 8 holes. All right, so there's my 8 mounting holes. Still need to be tapped. We're going to try and do that in tapping machine. That is the smallest it can do with the chucks I have. That's 1032. It's pretty small, or 1024. Little disconcerting, but we're going to try it anyways. It might be better to hand tap these. I did make the holes go all the way through, so that should make it easier. I can use a spiral point tap, which is stronger than a spiral flute tap. We will see. Next up, we're going to do the slotting. So we're going to do 75 thousandths deep slots, and this whole thing is going to be kind of a pain, but we're going to use the knee to go up to 75 thousandths. And I'm going right in the middle where I've pre-drilled the hole, so that'll make it somewhat easier. Now that I've got the depth, I'm going to lock it off my knee, and we're just going to walk it out until I get to plus or minus 2.844. And we're going to find our depth again after I tighten that collet a little better, or maybe put in a different collet holder. I don't have a Weldon flat cutter, carbide cutter to fit in here, but I did have a 2-flute which produces less force, so we're going to try that. And this cutter is all the way up in the holder, so it can't be pushed in. Cut does not feel like a lot to me. I'm not sure why it's having such a problem with it, but it definitely is. Now we have to do 2 this direction. I think this time around we're going to set our partial depth. We're going to do all 3 slots in this direction, then come back and do finishing. Okay, that finishes most of it. We're going to definitely take it over the surface grinder to remove all these burrs and just run it over there. The absolute locations of these square parts is not really important. Their job is to support the material that you're working on. So this part where I accidentally cut into it, that's not going to be a huge deal. All of my holes from the top part down are going to be in these intersections, so they just are for support, and if they're a little bit smaller, that's not a huge deal. I'm going to take this end mill out of here, and then I'm going to drill a hole because I got to meet up here with the NPT fitting. Here's a good reason why you have the leather under your end mill as you're removing it, because sometimes they pop out and you don't even notice. Like this one, there's enough suction to hold it mostly in, but not completely in. And it's very easy. If you have square corner end mills, it's very easy to break them.